Yes, hello everyone. Welcome to your physics classroom. I am Lawal Adetunji, your physics tutor. So welcome to your physics classroom. To our new viewers, welcome to physics classroom. Please do well to press the subscribe button, turn on your notification button, press your like and share, and put your comments in the comment box. To our returning viewers, welcome back to your physics classroom. As we have all known that we are still in the season of NECO 2025 and physics will be written in the next few hours. So this is our final revision on physics, and you know when we say final revision, you know what it means. Our returning viewers know what it means. New viewers, don't joke with it, that's the meaning. All right, I have questions here. We have questions from beginning to the end. Most of them have been solved in our videos. Please do well to watch videos on. We have solved question 1, 2, 3, 4, 5 in our previous video. Please check the playlist and look at the video. The video we are doing right now is talking about question number 13. Now, and I don't want the video to be too long, so please do well to watch the video from beginning to the end, because before the end you will still receive some special information that will help you. All right, all the information you need for tomorrow, they are all here. You don't need to rush. Now, without wasting time, we have the questions. Here I'm discussing question. I'm going to start from question number 13. That is the part of the section B. All right, the question that gave birth to this answer is talking about you should list features. It says you should list 2 features of a clinical thermometer other than the NIC. They say you should mention 2 features of thermometer. Here I'm giving out 3. I mentioned narrow ball, I mentioned short range, I mentioned constricted bulb, and I mentioned glass casing. The question is list 2. Let me show you the question. The question said list. Don't bother about the number I put there. Let me write the number properly. The number is number 13. Number 13. Alright, so they say you list 2 features of a clinical thermometer other than NIC, and we have seen the answer I mentioned: the narrow ball, the short range, the constricted balls. I mentioned also the glass casing. I think that one settled the question 13A1. Now let's go to question 13A2. Question 13A2 said, what is the function of that NIC? Well, I know several times if you have seen clinical thermometer, you will have seen what we call NIC on it very well. You also can do well to Google search and see the clinical thermometer and the part called NIC and what's the function of that NIC. The function of the NIC, they said you should mention 1. I'm giving out 3. As you are watching, please, as I'm talking, please do well to share the link with your friends. Share it with your friends. We have more than 50,000 people writing physics NECO nationwide. Share it, let it reach them, let us also benefit. Don't be the only one to benefit. So we can now say functions of the NIC. I have number 1, to prevent mercury from falling back. Another point mentioned there, I said it will retain what? Retain the maximum temperature, to retain the maximum temperature. And likewise, what again did I say? I talk about what again? I said it helps ensure accurate and steady readings. It helps to ensure accurate and steady readings. That's talking about question 13A2. Now I'm going to question 13B. Question 13B said you should state 2 negative impacts of energy used on our environment. I take it, state 2 negative impacts of energy use on our environment. Before I continue with that, please try to watch the video from beginning to the end, because I'll be dropping some meaningful information for you in the comment box. I will attach it to it, that is the instruction or the message I will drop in the comment box will link you to the remaining questions that have been solved. And likewise, you will see the channel that will talk to you about how you will see objective being solved. Okay, so your own is just to be following our instruction and watch our comment section where message we pin. Once ever we pin the message, it's meant for you. All right, I'm talking about states the 2 negative impacts of energy use on our environment. Okay, what are the impacts of it? You're also supposed to know that's supposed to be pollution, air pollution. So I'm coming with that. I have 1. I have it here. I said 1, air pollution, 2, global warming, 3, deforestation and habitat destruction. Another one here I mentioned, I think I mentioned 3, and they just asked you to mention any 2, so you have more than enough. You have access. I hope you are with your book and pen. Don't just be looking. Play back. You are the one holding your phone on your system to watch. Take your book and pen. Control your phone. Control your pen. Where you're supposed to by move, check it again to watch again to have the better knowledge. Do so. Do the needful. So that's why I say you should not skip. Do all what you need to get that success, that distinction you want tomorrow, physics. So we are giving to you live and direct what you need for tomorrow. And I'm going to question 13 C1. Question 13 C1 says you state the differences. State 1 differences and 1 similarities between ice and steam. We also know ice, what ice can be, and you know what steam can be. When you talk about steam, we are talking about something that the gaseous exchange, the gaseous state. And when you talk about ice, you are referring to something at the solid side of the form of water. So what's the difference between ice and steam? I think from that statement I've explained one. I'm still going to give you more than enough. I said something. When you talk about ice, you can remember your ice block. Once you remember your ice block, you remember the answer, that ice is solid, steam is gas. Ice is still solid, steam is gas. And when you talk about ice again, ice has a definite shape. Ice has a definite shape. But when you talk about gas, it has no definite shape. It's more or less saying that the difference between solid and gas is what they are bringing out there. And lastly, I mentioned ice is closely packed. That is, the particles are well packed. But for the issue of gas, they are widely spaced. I want me to give you one more. What can you say about speed? Put your answer in the comment box and let me see how you can reason with me. Alright, I'm moving to similarities now. What are the things that make ice and steam to look alike? I have it here. I said when you talk about water, when you talk about ice and steam, both of them are what? Are forms of water. Yes, water at a solid state is ice. Water as liquid state, at gaseous state is steam. Yeah, that statement is correct. Both are forms of water. Another one say both undergoes phase. Yes, both of them undergoes phase changes in temperature. When you talk about phase, one undergo fusion. That is relation between liquid solid fusion, that is ice, is fusion. And the one that deal with vapor, that one is vaporization. You can still remember, I'm using that one to remind you of your latent heat of vaporization and latent heat of fusion. That's what I'm sending you to. And likewise, number 3, both of them they have thermal energy. That both of them can be experienced under thermal physics. So both of them have thermal energy. They have heat energy. That's the simple meaning. And the next question here is a calculation question. It's talking about the question that contains both heat capacity and latent heat. And what's the question saying? It said 100 grams of steam was cooled to a temperature of 25 degrees Celsius. Calculate the heat lost to the surrounding. You are given latent heat of vaporization, that is 2.26 times 10 to the power 6 joules per joules per kilogram, and that of specific capacity of water, you have 4.2 times 10 to the power 3 joules per kilogram per Kelvin. So we have all these together as a question, and to solve the question, the first thing you need to know, you convert your mass to kilogram. You convert your mass to kilogram, and they give you initial temperature. Initial temperature of the water is 25 degrees Celsius. And you talk about steam, you need to know that water boils at 100 degrees Celsius. That is your final temperature is 100 degrees Celsius. So leaving that side again, they gave you your specific latent heat of vaporization. They gave you your heat capacity, and she said you should find the heat loss, that the heat of the system, the heat loss to the surroundings. And I'm very glad to let you know that from my solution here, I first interpreted every parameters. After the interpretation of parameter, what next did I do? I brought out all what I need to let you know heat loss means the total heat in the system, and I said ml plus mc change in temperature and the likes. You also do it and put your answer in the comment box. do it and so with the final answer here I got heat loss. When I put it together, remember I said my heat loss is total addition of the two energy in the system, and at the end of the day I have this. I believe you can see it clearly. Please take your time to watch the video very well. I think I have used that one to settle all question number 13. Now let me just flash you back to some of the question A we did. We have these questions and we have their answers. I think we have their answers somewhere around. We did some of them. We have answers to some of them. We have answers to some of them. So please do well to watch our videos on all those ones. And likewise check your comment box. I will drop the link that will also link you there. Alright, let me continue with the remaining questions. I am going to question number. I have settled question. I'm going to question number 16 now. I'll go to question number 16 right now. I'm going to question number 16. Now, looking at question 16, they ask us to define diffusion. They ask us to define diffusion, and you can see very well. I gave it to them that diffusion is a movement of particles from a region of higher concentration to the region of what? The lower concentration. That's talking about the definition of diffusion. And likewise, I think there was an illustration that described the journey of liquid A and liquid B by dropping a ball bearing into both liquid. That is, one of them is a liquid. That is, one of them is like a liquid without viscosity, and the other one look like a grease. So in a situation like that, they now ask the question of what happened there, and I said, what will you do? Drop a ball. We want to determine what here we want to talk about the story of viscosity. That's what we are bringing out there. As I said, drop a ball bearing into liquids A and B using the same cylinder and stopwatch. That is, we want to carry an experiment that will describe viscosity. That's what we are doing here. An experiment that will describe viscosity. That's what we are describing here. And how can you know that? You just have liquid A, liquid B. Maybe one will be water, one will be oil. So when you place your ball, you now time then how the ball will reach the bottom of the container or cylinder. So the one that gets there faster will be less. That one will be called less viscous. The one that gets there later, that one will be viscous. You know what oil can do. That's why I said the liquid in which the ball falls slower is more viscous. That is the one that is drawing, that the ball does not reach the bottom of the cylinder easily. That one is more viscous. So I have explained 16A. I have explained 16B. 16A, 16B. I have explained. Now I want to move to 16C. There they ask us to state two differences between X-ray and gamma ray. But here I'm giving out three. State two differences between X-ray and gamma ray. I am giving out how many? I'm giving out three differences. And they said mention two similarities between X-ray and gamma ray, and I'm giving out 3 points. Number one, both X-rays and gamma rays are electromagnetic waves. Both of them are electromagnetic waves. That is, both of them are examples of electromagnetic waves. That's the meaning. Another one is both travel at the speed of light in a vacuum. Both of them, they travel at the speed of light in a vacuum. And another one talking about both are used in medical and industrial image. X-ray, you can use it. Gamma ray, you can use it in industry to do a lot of purposes. So that's talking about 16C, and I'm going to 16D. I'm going to 16D. And what is the 16D all about? 16D is telling me something, and what is it saying? It gave me questions on atomic physics, where the photons, rather, they gave me frequency of 2.14 times 10 to the power 15. They gave me the Planck constant 6.6 times 10 to the power minus 34 joule seconds. And likewise, they gave me kinetic energy of 1.09 times 10 to the power minus 18 joules. And they asked me to find the energy of photons. Everybody knows that formula for energy of photons is E equals to HF. E equals to HF. So from there, you've known that putting it together, we have this answer. You also can do that one and put your comment in the comment box. And I move to my last question for number 16. I don't want the video to be too long, that's why I'm rushing. You also please do well to press the subscribe button, turn on the notification button, like and share the program with your friends and family. Thank you. So work function, everybody know that energy of photon is work function plus kinetic energy, but this time around we want to make one function the set of formula, which means that energy of photon minus kinetic energy. And they are giving no kinetic energy in the question. Energy of photon is what we got in the first one, so putting it together I have this answer. With this I have settled question with you. I've settled question number let me check the question that I settled with you now. I have settled question number 13 and 16 with you on this video. For question number 15, I'm saying it right now, for question number 15 you will see the answers to that one in our second channel, Estimator Adetunji Edu Consult. I'll put the link in this video comments. I'll put the link. I'll put all of them inside the comment box, so you click, you will see question number 15 and some other questions there. And while for the objective, I will drop the WhatsApp channel that will take you there for that. So please follow the link. I will drop it in the comment box. Please do well. Just turn on the notification button. It will be notifying you, because mathematics tomorrow will be live. We start by 7 o'clock, so that we'll be able to finish on time. We have also done live on physics tonight, and which has also treated question 1 to almost question 10. So I think that one is there. We'll meet in the next video, and bye for now.